Hi, Intro to Chem. We are going to do a review for your final exam. Your final exam will be week 11 and it will be proctored, and I want to make sure that you guys are totally prepared for this. I do cover every single final exam question in these 35 slides. So I highly recommend that you print these, live by these, and possibly make some note cards out of these. It will be very, very helpful for you. All right, so first we'll talk a little bit about safety. Know some of the safety rules, obviously no dangling jewelry, lip balm, gum, food, applying contacts in the chemistry laboratory. Healthcare workers need to be competent and follow dress codes. You want to make sure you're wearing a mask and gloves. And you need to ensure that the employee follows the safety program and provides a safe work environment. For example, you don't want any frayed wires or anything like that. We always refer to our MSDS, or now they're called safety data sheets, when it comes to chemical spills or handling chemicals as well. One of the first things we talked about after safety was numbers and glassware. For example, how many significant figures? You do have a significant figure question in your test. If you have questions on that, make sure you go back and you look at it. You don't have to calculate any logarithms, but know the definition that a logarithm is the inverse of an exponential function. Know what the SI units are. We use Kelvin for temperature is considered an SI unit, seconds for time, kilograms for weight, liters for volume. Those are all the metric system. An example of something that's not would be like a quart. That is the English system. Know about different things for measuring. We want to use things that are most precise. Out of this list here, beaker, graduated cylinder, and volumetric flask, a beaker would be the least concise. Usually the larger the item is, the less concise it will be, or less precise it will be. Know about some organizations. And know about the different types of laboratory departments. So in the clinical laboratory, we perform clinical and microscopic tests. We also have microbiology, hematology, immunohematology, and urinalysis. Know that OSHA refers to workplace safety, and that NACLS accredits things like Rasmussen College's MLT program. All right, matter and its physical transformation. Terms that you need to know. There's 2 or 3 of these on your test. Understand what vaporization is, going from a liquid to a gas, condensation, going from a gas to a liquid, and sublimation, which is a new one most of us haven't really heard about, but that one is going from a solid to a gas. You will have a couple temperature conversions on here. Make sure that you know how to convert Fahrenheit to Celsius, Celsius to Fahrenheit, Kelvin to Celsius, and Celsius to Kelvin, okay? You will have at least 2. So this is a good review slide for you. When it comes to wavelength and energy, know that energy increases as we go lower in the visible light spectrum or towards the gamma rays. But the longest wavelength is red. Okay, the shortest wavelength would be purple when it comes to visible wavelengths. Here's what you need to know about the periodic table and valence electrons. Know what a pure elemental substance is. So that's all one element, for example, bromide that you can see here, Br2. Understand the difficult elements. These are the ones we refer to more often than not in clinical chemistry. For example, Na is sodium, K is potassium, and Fe is iron. Those are the difficult ones, and you will have to know one of those on your test. Know that the columns are groups, and the group number determines the number of valence electrons. For example, neon has 8 valence electrons. That is super important. Know what the octet rule is. So that's the chemical rule of thumb that reflects the observation that atoms of the main group elements tend to combine in a way that each atom will have 8 electrons in its valence shell, giving it the same electronic configuration as one of the noble gases. Hydrogen never obeys that rule. Know that ionization energy decreases from top to bottom and increases from left to right in a period. Cations and anions. Negatively charged ions are anions. For example, chloride has 17 electrons. When it has 18, it becomes Cl- an anion. Positively charged ions are cations. When it comes to looking at the molecular shape and it's drawn flat on a piece of paper, you will have a question on this. A wedge is projecting out of the page, a broken line goes behind the page, and a straight line is in the plane of the page. Molar mass. Be able to calculate molar mass, as you will have to for, excuse me, a couple of your molarity calculations you'll have later on. So how much does 1 mole of H2SO4 weigh? 98 grams. There's 2 hydrogens, a sulfur, and 4 oxygens in there. Okay. The next one, dimethylnitrosamine, which is CH32N2O, is a carcinogenic or cancer-causing compound that can be found in foods. The molar mass of that one is 74. So try practicing, seeing if you come up with 74, adding these things together. That one's a little bit more difficult. Couple different types of bonds to be familiar with, covalent and ionic bonds. With a covalent bonds, the electrons are equally shared. Examples are carbon monoxide, NO2, silicon SiO4, and H2, which is just pure hydrogen. It can be 2 nonmetals or metalloids that are covalent. In an ionic bond, the electrons are actually transferred. This definition is a strong lattice of positively and negatively charged atoms held together by electrical forces. Examples are lithium chloride, magnesium chloride, ferric oxide, and H2 can fall in that. Well, sorry, H2 should not be on there. Cross that off. London forces. Okay, these are weakly attractive. They occur between polar and nonpolar molecules, and they're also called dispersion forces. Know the ideal gas law and be able to convert depending on what it is you're looking for. For example, PV equals nRT, or to solve for V equals nRT over P. The volume occupied by 16 grams of water vapor at 110 degrees Celsius in 1 atmosphere. If you want to go ahead and pause here, try and figure this out, and then I will go on with the answer. For this one, the number of moles, or 16 over 8, equals 0.88. R is 0.082. The temperature is Kelvin, so 110 plus 273.15 is 383.15. The volume is 0.88 times the 0.82 constant times 383.15 divided by 1 gives us 27.5 liters. Okay, so if you know how to do basic algebra and move this equation around, you should be able to figure out any ideal gas law problem. Next, looking at balancing equations. Know that nothing is lost in the equation. In order to balance an equation, you have to make sure that there's the same amount of items on one side as there is on the other. And here are some examples for you to use for practice. You will have one very similar on your test. Understand reactions. We have decomposition, combination, single replacement, and double replacement. You will need to be able to recognize what type of reaction is present when we give it to you. So one of these will actually be the one on your test. Understand that if you have 2 things together and they break up into something, that's decomposition. When you have 2 things combining, that's combination. When you replace one thing at single replacement, replace 2 things as double replacement. Another note that I have down here, temperature, the concentration of reactants, and the surface area of solid reactants they do increase the speed of the chemical reaction. Those are the 3 things that increase the speed of the chemical reaction. All right, when it comes to chemical kinetics, how slow or how fast these things work. A larger energy of activation means a slower reaction rate. The higher the energy activation barrier, the fewer reactant molecules will have the energy to surmount the barrier per unit of time. So if the energy of the reaction is less than 0, it's exothermic. An example is combustion. And if it's greater than 0, it's endothermic. For example, melting ice. Understanding acids and bases. The lower the pH, the more acidic. The higher the pH, the more basic. A low pH is usually less than 7. It yields hydrogen ions, and basic yields hydroxyl ions. When it comes to electricity, know the difference between electricity and an electrolyte. Electricity is the flow of electrons, where an electrolyte is any salt or ionizable molecule that when dissolved in a solution will actually be able to conduct electricity. A very common one you're familiar with is NaCl, that's typical table salt. Oxidation states and numbers. This is difficult. This is not something we expect you to be very well versed in. The example that you will have on your test is identical to the problem we see here. What is the oxidation state of oxygen in KClO3? Okay, so read this slide, know how to do this one, and you'll get that right on the test. Redax reactions. Some people use the analogy oil rig. In oxidation, the oxidation agent, you can see here methane is oxidized and it loses the electrons, and oxygen is reduced and it gains the electrons. With reduction, the reducing agent is methane reduces oxygen and itself is oxidized, and the O2 is reduced, gains electrons, and the methane is oxidized, it loses electrons. You just need to be able to know which one the reducing agent would be, and the one on your test is very similar to what you see here. Equilibrium constants. These state where the equilibrium of a reaction lies at a given temperature. Know that KEQ equals the products over the reactants. We put the concentration of the products at equilibrium on the top and the concentration of the reactant at equilibrium on the bottom. At equilibrium, the forward reaction rate is equal to the reverse reaction rate. That's important to know as well. Here's an example. This is the same example of the question you'll have on your test. Calculate Ke2 if N2O4 is 0.05 and 2NO2 is 0.210. Oh, sorry, I'll go back. Oh, well, let me go back. That was the example was there. Okay, synthetic compounds, getting closer to the end here. A polymer is a very large molecule made up of thousands or even millions of atoms that are together in a repeating pattern. Petroleum has covalent compounds that are the source of many polymers, fertilizers, insecticides, and plastics. It's mainly carbon and hydrogen. And the nylon is used in many types of clothing and in other applications such as ropes. The strength is due to the hydrogen bonding between adjacent polymer chains, and it forms an amide bond between units. So those are important. All right, what are macronutrients? Well, proteins consist of amino acids. All amino compounds have nitrogen in them. Okay, so that's important. Essential amino acids are the ones that we have in our body that we cannot synthesize. Enzymes are proteins. They essentially contain shaped pockets that only fit certain reactant molecules that speed up the reactions. Know what a polysaccharide is? It's many sugars put together, such as a starch or a complex sugar. And then we have fats, which consists of things like lipids. When it comes to radiation and isotopes, be able to recognize what an isotope is. For example, 16 oxygen, 17 oxygen, 18 oxygen are all examples of isotopes. Then we have nuclear fission and fusion. Fission is the splitting, and fusion is combining. Be able to calculate a solution. You will have one of these on your test. A dilution is a solution made less concentrated by adding a diluent. The diluent does the dissolving, and the solute is what's being dissolved. For example, if we put 100 microliters of plasma with 200 microliters of water, we'd have a 1:3 dilution. 200 plus 800 is actually a 1:5. And you might be saying like, well, why is it 1:5? Well, we do have to make the 1 be on the top. So if you doubled well, I don't say if you doubled everything, but if your total volume is 1,000, it would be a 1:5. A serial dilution, just kind of know the definition. A sample is diluted a series of times by a factor. You guys will be doing a lot more of these in clinical chemistry. Be able to calculate a volume per volume, weight per volume, and weight per weight. Volume per volume is a liquid plus a liquid. For example, 10 mils of bleach plus 90 mils of water is a 10% bleach solution. How many grams of solute do you need to make 200 mils of a 20% weight per volume solution? Well, this one uses grams and mils. So you would take the 200 times 0.2. You have 40 grams of solute, add it to the container and fill to the 200 mil mark. Weight per weight is a solid plus a solid. That's not very common. Be able to calculate a C1V1 equals C2V2, where you have the concentration of one thing and the volume of one thing equals the concentration of another times the volume of another. I always say you've got three things and you're looking for the fourth. So for example, here's what you have, and it also says here's what you have and here's what you need is usually what you see. You have a 10 mil hydrochloric acid stock solution available, but you need 100 mils of a 1 molar, okay? So you put the 101 on one side and then the 10 times X on the other side. In this example, you need 200 mils of a 20%, but only have an 80% stock glucose on hand. Here you take 200 times 20 equals 80 times X and solve, and you'd get 50 mils of the 80%. Look for terms like have and need for these equations. All right, for molarity, we got some examples here. I'm not going to go over each one. These are some practice ones for you. If you've memorized these 5 here, you'll be able to figure out all molarity, liter, moles, and gram type problems. Also, one of the biggest mistakes I saw in your homework is converting milliliters to liters. Notice we need liters here, okay? So if you have 250 milliliters, you can't use that. You have to use 0.250 liters. Okay, that was a big issue that I saw in the homework, so make sure that you're converting those over. And one of the last types of things we had was quality control. You're going to want to be able to do these things. So proficiency sample, know that that's a blind sample result that compares it to other laboratories. Okay, make note cards out of these if you have to. Know that a standard has a known concentration, which is exactly like 100 milligrams per deciliter. We use this for calibrating things, for the process of checking, standardizing, and adjusting a method of an instrument. And a standard can also be called a calibrator, okay? Know that a quality control sample has a known range of concentrations, such as 100 to 110. This is what we run on everything to make sure it works. Know that a Levig-Jennings chart plots QC. That's what you see in the bottom corner here. And you can see we have a shift is sudden. Okay, we got a shift here, suddenly shifts down. We can have a trend, which happens slowly over time. It's more of like climbing a hill or going down a hill. Know the definition of these and how to calculate them. The mean is the average. So if I say find the average of these numbers, add them all together and divide by the number of numbers that you have. Know that the mode occurs most often and that the median is the middle. Be able to calculate standard deviation and coefficient of variation. So in order to calculate the standard deviation for these numbers, you should get a standard deviation of 16. I want you to run through these in practice and see if you can do the steps. What is the standard deviation for a set of 10 numbers that is a mean of 100 and this part of it being 3,500? Okay, so that's just like the summation part here. You should get 19.7. And I'll tell you right now, you have a question on your test exactly like this one in the middle, okay? Be able to calculate CV. CV is easy. Standard deviation divided by the mean times 100. Okay, a CV less than 10% is good. Quality control. Know that 68.2, 95.5, and 99.7 are confidence intervals. We use a Gaussian bell-shaped curve for this. Know that the mean plus or minus 1 standard deviation is 68% of the observations. Plus or minus 2 is 95.5 or 95%, and the mean plus or minus 3 is 99.7, which is like almost all the data. That's why we only go up to 2 standard deviations with our data. Going all the way to minus 3 plus 3 would be like including almost everything. All right, last slide. The first step with QC being out of range is to recheck your QC, run it again, right? Here's some other things with the Westergaard rules. Know that 1,2S is the only one that's a warning. If something is out 2 standard deviations one time, that's a warning, okay? If it's out again, then it's a rejection, which means we cannot continue using that analyzer or that method. We need to make sure that the analyzer is working appropriately. And Westergaard rules allow us to monitor that quality control to make sure. All right, and that's everything for our review. This is a great tool. Every single question is covered within this PowerPoint. I will also be posting a Quizlet for you guys to help you study for your final exam as well, so please watch for that this week. If you have any questions, please feel free to reach out.